week 9. Um, I, I hope you know the tutorial sheet. If you don't know the tutorial sheet, you can go to the, I'll show it to you now. This is the course website. You should go down to week 9. The tutorial sheet is this one. But as you can see, there are 7 questions. I will try to do as many as I can, okay? All right, guys, so let's start with question number 7. So I'll start with question 7 and work backwards, all right? If you cannot see the screen, or please give a shout, okay? So this is question 7. There are 4 different parts to this question. So I will start with part 1 of question 7. So excuse me. So this is question 7, part 1. Okay. What you're given is a variable y defined as ax plus b, where a and b are constants and x is a random variable. So y is also a random variable. Okay. The question is to find the mean and the variance of y in terms of the mean and the variance of x. So we are talking about the population mean, right? So let this denote the population mean of y, okay? So this you can write as the expectation of ax plus b, right? And if you take the expectation inside, this will be this, right? Now the expectation of x, I'm going to denote that by mu x. All right, so you see what I have shown. I have shown that the population mean for y is 8 times the population mean for x plus the constant b. All right, now similarly for the variance, the population variance of y, which is this, right, is equal to this, right? Now if you take the variance inside, it will become a squared times the variance of x. Remember, b, the plus a constant, minus a constant does not change the variance. I'm sure you know that from Pro-Blut 1. So this is a squared times the variance of x, which is this. Right? All right, so this completes. So here I have expressed the population variance of y in terms of the population variance of x. So this completes the first part of question 1. The second part of question 1 is to express the sample mean of y, which, as you know, is this, right, in terms of the sample mean of the x's, right? So let me do that. yi, we know yi is axi plus b, okay? Now taking the summation inside, this will become in brackets a times the sum of xi, right, plus the sum of b. Okay. Right, now this Now the sum of b is a constant, so the sum of b is n times b, right? All right, now if you divide by n, you get a multiplied by 1 over n times the sum of xi. Okay, if you divide this by n, you get b, right? Now what you have here is the sample mean of the x's. So what you have is a times x bar plus the constant b, right? So what I have expressed is the sample mean of y's in terms of the sample mean of x, right? So y bar is a times the sample mean of x plus the constant b. Right, are you guys okay so far? Any questions, please use the chat room, okay? I'm most happy to help you to answer any questions you have, right? The next thing I'm gonna do is look at the sample variance of y, right? You know that the sample variance of y is defined by this. Yeah. So this is 1 over n minus 1, the sum. Now yi, we know yi is a xi plus b, right? And we know from here that y bar is ax bar plus b. So you have a x bar minus b. Okay. And these two guys cancel out. Okay. So what you have is the following. You have a squared times xi minus x bar squared. Now a squared is a constant, so this is a constant, right, with respect to I. So you can pull it outside. So this becomes a squared multiplied by okay, all right, okay, and finally you can write this as a squared multiplied by, now what you have here, which you may recall, is the sample variance for the x's. So this is simply sx squared. So we have shown that the sample variance of the y's is equal to a squared times the sample variance of the x's. All right, guys, are you okay with this, or any questions you have? Please let me know. Hello. You guys okay or not? Talk to me, guys, please. All right, thank you. Right. All right, the next thing I'm going to talk about is the third part of question 7. Excuse me. So this is question number 7, part 3, right? Now what you are given is the following. You are told that oh, sorry. Okay, you are told that this interval is 100 times 1 minus alpha % confidence interval for mu x, right? So which implies that, I'm sure we've been doing confidence intervals so far. So which implies that the probability that right? This statement here is the same as this statement, okay? Now what I'm going to do next is I'm going to multiply everything within the brackets by A. Like this. And the next thing I'm going to do is I'm going to add, for each of these terms, I'm going to add the constant B. Okay, all right. Now we know from the first part of question 7, that this guy here is the population mean for Y. All right, so in the next step, I'm going to replace this right? So you see that the population mean for Y lying between these two has a probability 1 minus alpha. Now what this implies is that the interval from this to this all right guys, so starting from a confidence interval for mu x, I have established a confidence interval for mu y. Okay, are you able to hear me, or is the screen freezing? I think I have problems with the internet. If you cannot hear me, please let me know, okay? Or if you cannot see my writing, because my internet is not stable today. I don't know, for some reason. Hello guys, can you hear me or can you see me? Okay, thank you. I'm just telling you in advance because my internet has been playing around all day. All day yesterday and today. All right, so this is part 3 of questions 7. Now, the next part, is question 4, part 4, question 7, part 4. And what you're told here is the following. You're told that the interval from this interval, right, is okay. You're told that this is 100 times 1 minus alpha percent confidence interval for this, which implies the following, that it implies that the probability that okay, right guys. Now what I'm going to do in the next step is I'm going to multiply each of these terms by a squared. All right, so you get a squared Vx less than or equal to a squared right? Now we know from the first part of question 7 that this guy here is the population variance for Y. All right, so in the next statement, I'm going to replace this by sigma y squared. Right? So you see that the population variance of y lying between these two has probability 1 minus alpha. Now what this implies is that the interval from this to this right? All right, guys. So what I've done here is to start with the confidence interval for sigma x squared. I have constructed a confidence interval for sigma y squared by these steps. Okay. Any questions on this, guys? Are you okay with this? Is the last part of question 7? Are you guys okay or not? If not okay, please let me know. I'm happy to go over things with you. Right. Okay. Hello, guys. Are you okay or not? Are you sure? All right. I hope. Yeah. Okay. Thank you. All right. The next question. So I'm done with question 7. The next question I'm going to do is question 6. Now here, here what you have is a sample with size n equal to 30, right, from a population with the sample mean x bar given by this, sample variance given by this. And the question is to find a 98% confidence interval for mu and a 98% confidence interval for sigma squared. Now, you may recall last week I talked about 4 different confidence intervals, and these are the formulas. This is the confidence interval when for the population mean when the population variance is known. And this is the confidence interval for the population mean when the population variance is unknown. And this is the confidence interval for the population variance. And this is the confidence interval for the population proportion. Okay, so these are the 4 intervals I talked about last week, which was week 8. Now, in this, returning to this question here, we are given the sample variance, which means that the population variance is unknown, right? So in order to find the confidence interval for mu, we need to use this formula here, right? Remember, this is the formula when the population variance is unknown. Now, in order to find the confidence interval for sigma squared, which is the population variance, we need to use this formula. So to answer question 6, we need these 2, right, formulas. We need to use these 2 formulas. Is that okay with you guys? Do you understand my reasoning? Because this formula here applies only when the population variance is known, and this applies when the population variance is unknown. So we need to use this one, right? Okay, guys, so let's see how we can do this. So this is question number 6. Okay, here we go. So to find the confidence interval for mu, all right, I'm going to use the formula that I just mentioned, right, which is okay. This is the formula I'm going to use. Right now, x bar is given to us in the formula, which is 127.442, right? Plus or minus. This is the percentile of the t distribution with n minus 1. N is 30, so n minus 1 is 29. Alpha, 100 times 1 minus alpha is 98. So alpha is 0.02. So this is going to be 0.99. S squared is given us as 228.661, right? So S is the square root of this. And N is given as 30. So this is what you have. Now this guy here, you need to read this from the T table. I showed you how to do this last week. I don't know whether you guys watched the video or not, but if you haven't, please go and watch the video. There is a table, there's a table for the T distribution, which is on the course website under the link called formulas. If you click on the link named formulas, you will get to the table for the T, all right? And from that table, you should be able to read this. And if you read it, if you read this off the table, you will get something like 2.462. This is the value that you will get, right? So simplifying this, you should have a calculator. You should be able to get the lower limit as this and the upper limit as this. All right, so this is the confidence interval for the population mean. Right, now to find the confidence interval for the population variance, I'm gonna use this formula here, right? So that's gonna be all right, this is what you will get. This is the formula, right? Now, we know that, I mean, I just mentioned in question 7 that the formula for the sample variance has this divided by n minus 1, right? N is the sample size. So you can write this, as S squared. S squared is the sample variance, right? Okay. Right, now I'm gonna sub in the numbers, right? Now n is 30, so n minus 1 is 29. Now S squared is 228.661 divided by chi squared with n is the 30, so it's 29. Alpha is 0.02, right? So this is gonna be 0.99. All right, this is what you will get, okay? Now to read these two guys, to read this one and to read this one, you need to use the table for the chi-square distribution, which is again on the course website, right? So if you go to the course website under the link formulas, you will find the table. And if you read this, you should get something like 49.588. And read this, you should get 14.256, right? Okay. All right, so finally simplifying these things, the lower limit will be 133.73 and the upper limit will be 465.9. 0.15. All right, so this is the confidence interval for the population variance, and this is the confidence interval for the population mean. All right, guys, any questions, guys? Hello, guys, talk to me, and feel free to ask any questions you guys have. I'm happy to help you guys. So this is, hello, are you okay? What information can we find from confidence intervals? Yeah, it's basically telling you that the population mean lies between these two values with 98% confidence, right? And similarly, the population variance lies between these two limits with 98% confidence, right? So suppose you want to find the temperature in, suppose you want to find the temperature, the mean temperature in Manchester right now, you can give like a 95% confidence interval saying that the mean temperature is between this and that with 95% confidence, right? And that really helps, rather than just giving a point estimate, like instead of saying it is like 10 degrees centigrade or 11 degrees centigrade, it is much more useful to give an interval with certain level of confidence, right? Because it's never, the temperature keeps changing every second or every millisecond. So it's difficult to give a point estimate. And it is more meaningful to give a confidence interval, right? Okay, guys, so this is question 6. The next one I'm gonna do is question 5, is this one. So here you're told that sigma is 0. S squared, yeah, S squared is the variance, is the sample variance, Robert. Yeah, it's just a sample variance of a given sample. I don't know what you mean by entire sample. Yeah. So in question 5, you are given the population standard deviation as 0.05, and the question is how many measurements you need so that the 95% and the 99% confidence interval for the mean have width not exceeding 0.02. All right, so let's go back to this formula sheet, right? In this formula sheet, when the population variance is known, which is the case in this question, the confidence interval for the mean is given by this, right? All right, so what I'm gonna do, excuse me. So this is question 4. The confidence interval for the mean is x bar plus or minus z. All right, this is the confidence interval. Now the question is talking about the width of the confidence interval. Now the width of the confidence interval is the difference between the upper limit and the lower limit. The upper limit is this is the upper limit of the confidence interval, and the lower limit is this, yeah? So if you take the difference, of these two, you will get 2 times. All right, so this is the width of the confidence interval. Right now we are told that sigma is 0.05. Okay, All right, so 2 times 0.05 is gonna be 0.1. All right, so this is the width of the confidence interval, of the confidence interval. And we want this width, the question is saying we want this width not to exceed 0.02, right? Right? So we want this to be less than or equal to 0.02. So which implies, which means that root of n, right, must be greater than or equal to must be greater than or equal to this. And this is the same as saying that root of n must be greater than or equal to, this guy here is 5, 5 times this, Now if you square both sides, this becomes n. This becomes, the square of 5 is 25, and the square of this is simply this. All right, so this is the formula. This is the formula that gives the minimum sample size. Right, let me call this formula star, right? All right, now the question is saying is to consider 95% and 99%. So I'm going to consider part one. I'm going to consider the case where 100 times 1 minus alpha is 95, right? Which implies that alpha is 0.05, okay? And this implies that Z1 minus alpha by 2 is 0.975, which is 1.96, right? Now you should go back to star, right? Star implies that n must be greater than or equal to 25 times 1.96 squared, right? Which is 96, you should compute this, 96.04. Now remember, n cannot be a decimal point. N is a sample size, it must be an integer, right? So the smallest value n can take must be 97, okay? Okay, guys, so that's part one. Part two is to consider the case where 100 times 1 minus alpha is 99, okay? So your alpha is 0.01, and your Z1 minus alpha by 2 will be Z 0.995, right? And if you read this off the table, it will be 2.58, okay? That's from the normal table, which is in the course website one more time, right? Okay, so if you sub this into equation star, which is this, you will get n greater than or equal to 25 multiplied by 2.58 squared, and this is equal to 166.41, right? And again, n must be an integer, so the smallest value you can take is 167. All right, guys, so this completes question 4. Are you okay with this or no? Any questions on this, guys? Please let me know, please. Hello, guys. Talk to me, guys, please. Are you okay with this? Any questions? All right, thank you guys. That's question 4, we are done. All right, the next question I'm gonna do is this one. So here, if you read it, it says that sigma squared is known. Remember, sigma squared is the population variance. And we are looking for a confidence interval for mu. We are looking for the width of the confidence interval for mu. And we want to see which variables affect the width, right? So let's see how we can do this, right? So this is question 3, right? So question 4, question 4, right? This is question 4. Now, once again, the confidence interval, the confidence interval for mu is this one. Is x bar plus or minus . Yeah, remember, that's because we are assuming that sigma squared, the sigma squared is known, right? So this is the confidence interval, right? Okay, the width, of the confidence interval is the difference between the upper limit and the lower limit. Right? Okay. Now, if you take the difference, I think I did this already before, so it's going to be 2 times, this is the width, right? Now, if you look at this, formula, there are 3 variables that control the formula, right? Namely alpha, sigma, and n. So alpha, sigma, and n. Okay, let's see how they control. Now, are you guys familiar with this notation? This means alpha increases, right? As alpha increases, Z1 minus alpha by 2 decreases, right? So this is the quantity that contains alpha, right? So as alpha increases, this decreases. So the width will also decrease, right? All right, guys. Yeah. Okay. So I hope you know what this notation means. It simply means as alpha increases, the value of this decreases. Hence, the width also decreases, right? Now, as sigma increases, sigma is in the numerator of this formula, right? So for larger values of sigma, this will get larger, right? Okay, so as sigma increases, the width will also increase, right? And finally, n, as n increases, remember, n is in the bottom of this formula. So for larger values of n, this will get smaller and smaller and smaller, right? So the width will get smaller and smaller. All right? Are you guys okay with this? So these are the description about how each of these control the formula for the width of the confidence interval, right? The next thing you are asked to do in question 4 is the following. You're asked to tabulate the values for the width for for different n. All right, these are different values for n, and also for different values of alpha. Sorry, 0.1. Okay, and also taking sigma to be 10. All right, so what I'm going to do, guys, is the following. I'm going to compute the value of the width for different combinations of alpha and n. You know what I'm saying? So I'm going to compute, right? So I'm going to like, for example, when alpha is 0.1 and n is 5, I can compute this with sigma equal to 10. And this is what you will get. You will get 14.71. You should compute this for alpha 0.1, n is 5, and sigma is 10. Now for alpha 0.1 and n is 15, you will get 8.49. Yeah, and if you do this, keep doing this, this is what you will get. Right? So these are the values of the width computed using this formula for different combinations of n and alpha. Right? Now what you're asked to do next is the following. You're asked to plot the width versus n. And if you do that, this is what you will get. Hope you can see this. So on the y-axis, you have the width. On the x-axis, you have the values of n. Right? And as you can see, the width decreases as n increases. Right? And there are two different lines. This line corresponds to alpha equal to 0.21, and this line corresponds to alpha equal to 0.1. So as you can see, as alpha increases, the width decreases. That's another thing that we observed earlier, right? Okay, guys, so this is question number 4. Are you guys okay with this before I do the next one? Hello, guys. Hello. You okay with question 4? Okay, thank you. All right, so we're done with this. The next one is this. You have, the question reads as follows. You have a random sample of 500 households. 80 were found to have 3 or more television sets. Find an approximate 90% confidence interval for the proportion of households having 3 or more TV sets. So this question here is on proportions. Now, if you go back to the formula sheet, I gave you 4 different formulas last week. These are the 4 formulas. This is for the mean of the population. This is also for the mean of a population. This is for the variance of a population. And this is for the population proportion. So we're gonna use this formula here to do question 3. All right, okay, so here we go. So this is question number 3. Okay, the formula that I'm going to use is the following: x bar plus or minus okay, right. Now I need to write down that what is given to us, right? So let me put this in the box first, right? Now we are told that the sample size is 500, right? And x bar, remember x bar is the sample proportion. This is the sample proportion. The sample proportion is 80 divided by 500, because 80 of the 500 households were found to have 3 or more television sets. So that's the sample proportion. And if you work this out, this will be 0.16. And we are looking for 90% confidence interval. So 100 times 1 minus alpha is 90, which implies that alpha is 0.1, which implies that this guy here is, if you read this off the table for the normal distribution, you will get this. Okay. All right, so let me put this in a box. All right, okay. Now you should sub this into this formula here. Right, you should sub this into this formula. This is what you will get. You will get 0.16 plus or minus 1.645 multiplied by 0.16 times 1 minus 0.16 divided by 500. Okay. Now you should simplify this. The lower limit will be this, and the upper limit will be 0.187. All right, so this is the 90% confidence interval for the proportion of households having 3 or more television sets. Okay, guys, is this okay, guys, with you? Hello, guys. Are you okay or what? Thank you. All right, the next question. So that's question number 3. We are done. So question 2. All right, to do question 2, to do question 2, there are 2 parts to this question. You're given a sample of size 30, and you're told that the sum of xi is this, and the sum of xi squared is this. And the question is to find the 95% confidence interval for mu when the variance is 30, is known to be 30, and the 95% confidence interval for mu and sigma squared when both are unknown. So to do the first part of the question, you need to, because the variance is known, you can use this formula here, right? Okay. Remember, this is the formula for the population mean when the variance is known, right? And to do the second part of the question, which is to find the confidence interval for mu and sigma squared when both are unknown, you need to use these 2 formulas here. So this is the formula you need to use for the population mean when the variance is unknown, and this is the formula that you need to use for the population variance. Okay, so unfortunately I have run out of time for today, but I will post the full solutions to all 7 questions later today. Today is Thursday, right? Yeah. So I will post the full solutions to all 7 later today on the course website. So you will see the typed solutions, the handwritten solutions, and also the video solutions to all 7 questions. All right, guys. So hope you like this tutorial, and if you have questions on the course or anything related, just feel free to contact me 24/7. Okay. By Skype, Zoom, email, or phone. I'm sure you know my phone. is 0161-273-2941. Okay, guys, have a great day wherever you are, and take care of yourself, right? Bye.
Thank you, sir.
Thank you. Bye.